Hi everyone, today we're going to be looking at the Click PLC EasyPLC Warehouse Stacker example. Now the Machine Simulator, or MS, is part of the EasyPLC software suite. It has many built-in machines that are used to show different programming techniques. The Warehouse Stacker example is one of these machines. Pallets are loaded and unloaded into the stacker machine. A maximum of 30 pallets can be stored. The stacker will work as a FIFO, meaning first in, first out device. This means that pallets are stored in a sequence and retrieved in a sequence. The Click PLC will be used to program this virtual 3D stacker machine. Indirect addressing, or pointers, will be used to track positions on the stacker, to store and retrieve the pallets. Using the Click PLC Plus, we will connect the warehouse stacking machine. This will be done using Modbus TCP or Ethernet for communications. Using the 5 steps for programming development, we will show how this FIFO is programmed. Let's get started. Detailed information contained in the video can be found at accautomation.ca. A link has been put in the description below. If you have not watched the other videos yet, there will be links to the description below that will start you at video 1. There will be links to the rest of the videos in the series as well. So if we go into machines, you will see that we have our stacker example right here, and if we click on it, we will see the information to the left-hand side. So it basically says the objective is to load the input boxes in the different locations of the automated warehouse. And once all are complete, the goods must be unloaded to the output conveyor. Now what we've done is we'll just start that, and you will see that we have basically a stacker right here. And so what we have to do is we have to release a pallet that goes onto a stacker. Then it gets loaded into these different slots that we see with our conveyor here. And we can actually move around in this environment just to give you a better idea. So we have, there's our stacker, and we will release a pallet. The pallet will go in here. The stacker then will go into these positions. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we have 30 total. So that's my last one here. So it's just counting up all the different numbers. And we then must unload them in the same example. So we load it in this position, then we hit the unload. It takes the first one that we loaded, and it's the first one out. So it's a FIFO scenario. So step 1 is always defining the task, and that's exactly what we are doing, defining what has to happen. Next is we have to view the I/O. So currently right now, if I hit view I/O, I can see how this actually works. So I can turn on my conveyor, and my conveyor turns on, and I can then produce a work part, and then I can stop the conveyor once I see the input signal. So you can see that input signal right here. And then the actual stacker itself, what you do is you put a position in, we'll say position bit 0, indicating 1. And then we will load this, or actually no position because we're at the load position right now. And then we hit the stacker strobe. And what happens is it picks it up automatically and moves it onto the stacker itself. Now if we hit unload and hit position 0 and then hit stacker strobe, it goes into position 0. Just like that. Now if we want to load that again, then we hit the load from position 0 and hit stacker strobe. It then loads that pallet up. And then we hit unload, and then we turn on all the bits indicating we want to go to the exit. We then hit stacker strobe, and it will place it on the exit conveyor for us. Once it's on the exit conveyor, then we can turn on the actual exit and then fire it off onto the end. So that's the basic operation. So we can see conveyor 2, and we'll just move this pallet out of the way. 2. So it's it's stuck there. So what we'll do is just restart the machine. There we go. Start right from the start again. We'll hit the View I/O, and again we have 2 other buttons on here. We have a load button and we have an unload button, and that will actually tell us when to load a stack or load the pallet onto a stacker, and unload to unload that pallet. So that is the I/O that we have, and you can see that we have light push buttons for our load and unload. Another couple of things we have is our door enable. So when we have our door enable, you can see I can open the door now, and when I do, I have my machine door open. If I close that door, turn off this, then I won't be able to open that machine door. So it's all interlocked already within the control itself. So that is the physical I/O that we have here. And we'll be using the Click PLC. So here is my Click PLC program for this. And if we look at our address picker, you will see that we have, we were going to use for our inputs, X101, which is our stacker end work, our photo cell input, our machine door open, unload push button, and load push button. So that there are inputs from our warehouse stacker. If we look at our outputs, we have our stacker position 0, bit 1, 2, 3, and 4. Then we have our stacker load or unload depending on what we want to do. Then we have our stacker strobe. Our conveyor roller 1 will advance it on our load side, so inputting to our stacker, and our roller conveyor 2 is the output side. Our machine door open permit, so it allows us to permit the machine door to open. We have our work part creator, and then we have our unload push button light and our load push button light. And if we want to see our Modbus display, we can actually hit this, and then you can see where our outputs start at 8225 and our inputs here at 100033. So that is our Modbus addresses for this program. So once we have defined our task, we defined our inputs and outputs, then what we want to do is develop a logical sequence of operation for our EasyPLC Warehouse Stacker. Now, a flowchart or sequential table or sequence table is used to fully understand the process that needs to be controlled. It must answer questions like what happens when electrical power or pneumatic power is lost, what happens when input and output devices fail, do we need redundancy? Typical questions like this. Now this step is where you actually spend a majority of your time understanding everything about the operation, and it will save you time. It will help prevent you from continuously rewriting your PLC program logic. Knowing all of these answers up front is vital to the development of the PLC program. So you can see here, when I develop my sequence, when looking through the I/O, I know exactly how each component works, especially that stacker or that loader. So I put it on, I have my, I'll just close that down. You can see that I put it on, I have my position here, I have my load or my unload, my stacker strobe, and then I get my stacker end work when the position has been moved to. So that is my sequence of operation. Now, once I have that fully understood, then I can go to my fourth step, which is the development of the PLC program. So if we go back to our Click PLC program, you will see here that we have the main program itself, and you can see my inputs, my outputs, and I have my analog to show on the display how many pallets are actually in the stacker right now. So the first thing we do is we do a load conveyor, and I'll just go briefly through these and then we'll look at a little more detail. So we load the conveyor, we have a stacker load and stacker store, we have a conveyor unload, then we have a stacker retrieve and unload, then we have a stacker position control and strobe reset. That's just to control that sequence to make sure that each one of these previous ones can actually store that. Then we have a stacker door operation enabled. So that is all of my parts of my program itself. So if we look in the stacker load, or conveyor load, what you'll see is that when I don't have my input signal and my stacker door is not open, and I don't have my conveyor load signal and it's not full, so we don't have the 30 pallets, then what we'll do is we will actually then turn on our conveyor load and we advance our conveyor roller. When we have that on, we automatically turn on our work part creator, and we keep that on for half a second, 500 milliseconds. That will create that pallet for us. Once the pallet has hit the input signal, so we have that advanced, then we set reset of the conveyor roller. So now we have a pallet sitting there waiting to load into our stacker. Now our load push button light. So when we do have our load, you'll see that we have a 1 second. So we have our load push button light actually flashing every 1 second. Half a second on, half a second off. When the stacker is full, we'll have the load push button fully on. And just to indicate that it's full, if we have the stacker door open, then it will also be on. So that gives you some indication to the operator that what's happening within that control or that unit. So that is my stacker load. Going back to the main program, you will see that we have now the conveyor load. Now we can do the stacker load and stacker store. So if we look at the stacker load and store, what we do is we have positions DS100 to DS129 indicating the 30 positions that we have to store the pallets in. Then we have a one address, DS50, that tells me my load position, and a DS51, which tells me my unload position of that unit. And then we have these bits that actually control all of our sequences. So C1, conveyor load, C2, load the input pallet, C3 is store the input pallet, C4 is load the retrieve pallet, and C5 is unload the retrieve pallet, and then C6 is the conveyor unload itself. So this code here will control C2 and C3 for our store, load and store of the input pallet coming in. So we saw C1, our conveyor, we have a pallet sitting at that sensor. So what the first thing we do is we want to load that pallet in. So once we have that pallet loaded in, then what we do is we will take DS98, and DS98 will contain the value 0, and we turn on bits or turn off bits C11 to C15. So we're using the copy to unpack that information, because all zeros load it from the input part of the conveyor, and all of the control bits are on will unload that pallet. Then what we do is we set our stacker load or unload. We will actually load it here, and then we turn on our stacker load sequence C2. Next, when we have C2, we delay half a second just to make sure that we have that value into our position bits. When we do, then we turn on our stacker strobe light, or strobe, to say perform the movement. This will actually move the pallet onto our stacker. Then next, what we're going to do is we want to set the position for storing the pallet. Now this is done through the indirect address of DS50. Now the pallet locations are numbered 1 to 30 as we said before. This is located in DS100 to DS129. So that means that the number in DS50 contains the value 100 to 129, indicating that location. So if we are on the step, then what we do is, provided all these conditions are true, we will copy DS indirectly from DS50, which contains the value 1 now because it's the first position, to DS60. And then we take DS60, we break that out and turn on the corresponding bits from C11 to C15. Then we hit the stacker unload, we reset it, and then we hit stacker store, which is C3. Then once we have our stacker store, we have a time delay of half a second, and then we do our stacker strobe to actually execute that command to move that stacker. Next, what we do is once the stacker has completed, then what we do is we reset C1 to C3, indicating that we have completed this load and store of our stacker pallet. Then we will take our indirect address DS50 and increment by 1. So we'll point to the next location, which in our case here, if it was 100, it would be 101. So the next, and then DS101 contains the value 2, which is the second position. Then we increment DS1, which is our number of pallets within our stacker. Then what we do is we look at our indirect pointer, and if it's equal to 130, that means it's past the 129 mark. Then we put a 0 or 100 back into DS50, so we reset that stacker or that pointer for that stack. And if the stacker is full, so the count is equal to 30 pallets, then we have a stacker full. So that is my stacker store. So going back to the main program, here we have the load, we have the stacker load and stacker store. Then we have a conveyor unload. So let's look at the conveyor unload. And what we do is just turn on this bit, provided that the stacker door is not open and the stacker is not empty. So if the stacker is empty, then we don't want to unload something or have it operate when there's nothing in there. Then we have an unload push button light. So the unload push button light, you will see will if it's unloading, there's a 1 second pulse and it will flash the unload button. Or if the stacker is empty, then the light will be on all the time. Or if the stacker door is open, it will be on all the time. So if the stacker door is open, we have both lights on, indicating it's full and empty, which means really the door has been opened and nothing will happen. Then we have when the stacker unload is complete. So after C5, if the unload is complete, we turn on the conveyor roller 2 and exit from there. And we keep that on for 15 seconds to allow that pallet to get removed from our stacker. Going back to the main program, after we've done our unload, then we have our stacker retrieve and stacker unload. So again, we have our sequence of bits here, and now we have DS51, which is our unload position, indirect pointer. So the first thing we do when we do the unload is we copy our unload position, which is DS51, into DS60, and DS60 then will control bits C11 to C15. Then we hit our stacker unload, and then we set our C4. Once we've set the position for our stacker retrieve, we then time out for half a second, and then we will set the stacker strobe on. Once we've completed that, then what we will do is we will set the unload position for the pallet, and this will be all 5 bits turned on. And we store that information in DS99. So that will turn on C11 to C15. Then it will say stacker load or unload. We reset it to unload, and then we execute our stacker unload, which is C5. So after the unload has been done, then we do a delay, again half a second, then we do the stacker strobe to actually perform that unload operation. And once the unload operation has happened, we reset C4 to C6. So all of our unload control bits. We also increment our unload pointer to the next address. And we will also decrement by 1 the total count. And then we will retrieve our pointer. We'll take a look at our pointer, and if our retrieve pointer is actually 130 or at the end, then we reset it back to 100 again. Now, if the stacker is actually empty, so there's 0 pallets, then we will turn on C8 to indicate the stacker is empty, and we will also reset both pointers back to 0. So there's no sense trying to track it through the system, you're doing our FIFO, when there's nothing in there. We just reset everything back to 0, so it starts for the very first pallet again. So once it's empty, we start all over and back to 0. And then we do a return. Next, what we have is our stacker position and control. And basically what it does is the stacker position, we've been using internal bits C11 to C15. They actually control our stacker position 0 to stacker position 4. So these 5 bits control exactly where we want to load and unload that stacker from and to. Then we have our reset stacker. So once we hit the strobe to actually start that after that time delay, this looks at the stacker end work. So once it's completely finished that movement, it will come back here and reset that stacker strobe for us. And finally, on our main program, we have our stacker door. If we call up our stacker door, you will see that if we're not loading our conveyor or we're not unloading, so C1 or C6, then we allow the door or is permitted to open. So that's we turn on the output. Now if the door is open, then we energize this bit saying the stacker door is open, and we don't allow any loading or unloading of the unit. So that is the program. And once we have the program now, we can go to the last step after developing the program is testing the program, and we're going to use this using the EasyPLC Warehouse Stacker. So let's go back to our main program here, and we will go back to our machine simulator. And what we will do is just go to our I/O drivers, and we will select our Modbus driver. We will configure this to the address of our PLC. And in order to get the address of the PLC, we go into our program again, and let's just call up our setup. And we can go to our Modbus TCP setup. You can see here port number 1. Right? So that's all set up. Then if we look at our COM port settings, we will look at our Ethernet port right here, which is port number 1 set up. And you can see here we have our address of 192.168.1.230. So that is our address for the Modbus that we want to put in. So let's cancel out of that. So we have that all set up in the program already. So again, going back to Machine Simulator, you configure this Modbus driver. You take a look at it, and you can see here our TCP IP port is set for 192.168.1.230, the exact same, and the default port of 502. Our digital inputs, so it's an input to the EasyPLC software. We'll start at address 8224. Now, when we looked at the Modbus addresses, they started at 8225, but this is a +1, so we do 8224, and we'll just put in a default of 15. The outputs start at 32, and we'll again 15, and then we'll have our analog. We'll do 5 of each, and our analog scale factor is now going to be 1. So we can put a scale factor in there so that we can modify or use this machine simulator with decimal points by using a scaling factor when it gets into the machine simulator. So very nice feature. Then we'll just hit OK. Once we hit OK, we see that everything's been brought back for us, and we can actually manually move each of the inputs, the PLC inputs, and the PLC outputs, the PLC outputs, or we can hit driver and automatically assign. And then we can automatically, you see that automatically assigns the inputs and outputs for us. Then we'll hit exit and start driver and exit. What this will do now is we have the driver connected to our PLC. And we can view the I/O. So right now, all of our I/O are now functioning as they should. If we look at the control panel, we can see that our display is now 0 here. So we don't have anything in the rack. And we can see that my empty light, my unload light is on, meaning that everything's empty in our rack. In the PLC, we just want to make sure that we are in run mode, which we are. It's located right down here. So the only thing else to do is we can actually now test it and run this program. So hitting the load, this should start flashing and bring in a pallet for us, which it does. It'll stop as soon as it sees the photo sensor. It will then energize the strobe bit and pick up and load that pallet. And we're going to go to position number 1, which is right here. And that's exactly what it's doing. And then we have now 1 on our count. And you now, because we have 1 pallet, you see our stack is not on now, so indicating that we do have 1 to actually unload if we wanted to. If we open the door, you can see that both of these now come on, indicating that, and now I can't start or stop any of these. So it works as expected, so we have to close this door in order for it to continue working. And let's just do 1 more. We load this up. So this is now going to be going into the first position, load it up, and then we will now load it into our stacker position 2 here. Exactly as we expected, and the movement's done, and now we have 2 on our stacker. If we want to unload, we'll hit the unload button. And now it's going to go grab that first one, because remember it's first in, first out. And it will move it to our output conveyor. It'll set it down, and then it will drive it back over. So that is our control program. So if you enjoyed this video, please hit the like button below. If you have any questions about the video, please leave a comment below and I'll do my best to answer it. If you want more information about us, or you want our free ebooks on numbering systems or robust data logging, please click on the link in the description below to get it. A new video is put out every Monday, so make sure you hit the subscribe button to get more videos like this in the future. Remember to click the bell beside your subscription to actually receive those notifications. Thanks so much for watching. I'll see you next time. Stay safe.